Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ. So I request you first, please pause the video, read the question, and whatever answer you get, please write in the comment box. You should try by yourself. So I believe you have done that. Let's start. Now look at the reagent. It is actually a ester containing amine hydrochloride. So you may consider, sir, it is a combination of amine. Obviously this R part is there. This part completely R plus HCl. So acid is already there along with the reagent. And if you look at other part of the reagent, NaNO2 sodium acetate. By the way, remember the sodium acetate's aqueous solution is basic because it undergoes salt hydrolysis to produce sodium hydroxide and acetic acid. This acetic acid is actually a weaker acid, so it dissociates partially, whereas this sodium hydroxide dissociates completely into Na plus and HO minus. So it is actually, the solution is actually basic. So these part provided basic solution, and here there is acid. So in combination, who will win ultimately? Ultimately win this HCl. Actually, if you look at this buffer solution, pH is closely acidic. It's a weakly acidic in nature. So in weakly acidic solution, what will happen? These NaNO2 will react this weaker acid and ultimately produce the HNO2 or nitrous acid. So in this way HNO2 will be produced, and these HNO, by the way, this is HNO2 looks like this. Now next step, it will undergo protonation. So these OH will be protonated, OH2 plus, and later on it will leave with this bond pair resulting in a electrophile formation, that is nitroso. Okay, so this nitrosonium ion is actually the electrophile which will react with amine. Now you will say, sir, this is an ammonium, so how amine will be generated? Recall how this H plus generated. The first case I have shown that this part basic, so that basic solution is quenched or reacted with this HCl. So consequently medium becomes slightly acidic. So right now this amine is not completely protonated. So it is an equilibration with the free from versus protonated from. So what will happen in the next step? Next step, this NH2 will act as a nucleophile. Nucleophile to whom? Obviously this NO plus. So this is electron deficient because nitrogen is carrying the positive charge, and after this nitrogen attacks, it will lose one proton and it will form this one, N double bond O. So N nitroso, this glycine ester, you may consider this way. Okay. Now next phase, this proton will be shifted from here to here. Such kind of mechanism I believe you have studied during diazonium salt preparation. So for this side OH, obviously N double bond N CH2 COOET. Next phase, what you can expect, that medium is slightly acidic, as I told, sodium acetate and this HCl from this ammonium part. So these acidic medium will protonate this molecule, this OH, and later on it will leave. So ultimately what is the product? You can expect, sir, this is the product. How? So this will push, it will leave. Now this is N, obviously carrying positive charge, CH2 COOH, sorry, COOET. Now here your question will be, sir, is it a diazonium salt? No, student. In the next phase, what will happen? One proton from here will come out. Come out means what is the product? So here CH. Now you can expect, sir, this is a CH minus attached to N nitrogen plus. So are you talking about this? Yes, student, I am talking about this. This is OET. Now next phase, these negative charge will come here. Consequently this bond will go there, means you can expect, sir, minus on this nitrogen, double bond, this nitrogen, and here carbon, hydrogen left, COOET. This is the product here, and obviously this nitrogen is carrying a positive charge. This is nothing but, student, you can write this way, N2 CH2 CO2ET. because I am just ignoring these two charges because they will cancel out each other, producing this final neutral molecule. So this is the product. I know it's a little lengthy mechanism, and remember this diazo compound could be stabilized because reaction temperature is 0 degree. So decomposition tendency of this diazonium from salt means diazonium derivative, diazo derivative, to produce this, actually not, I'll say YAM because YAM means cationic part says this is a diazo derivative, decomposition to corresponding nitrogen and carbon will be less. So under this condition, 0 degree centigrade water ether solvent combination, the product is, student, obviously option C. Now another thing, if you are little confused that sir I don't know how can I come back to the right answer, remember one thing. So here NH2Cl means it's an amine, protonated amine, and remember generally amines are stored as ammonium salt because if you keep free amine, I mean NH2, so this lone pair is free, there is a chance of oxidation because this electron density here, so that's why they are stored. So if you treat it with a weak base, this NaNO2, so HNO2 means NO plus, so fine, NO plus up to you are sure. Now it will react with a nucleophile. In this molecule there are actually three types of nucleophilic center, 1, 2 and 3. So which part, I mean NH2 not NH3, just consider this is NH2, this charge is gone. Which part is maximum nucleophilic, oxygen or nitrogen? Obviously nitrogen is more nucleophilic compared to oxygen, so consequently you can expect that reaction will happen here. If this nitrogen goes there, so this part is intact. So option A gone, option B gone, and obviously option D also gone. Who is remaining? Option C. You got your right answer. And another thing, if you say that sir medium is weakly acidic, so why this ester hydrolysis cannot happen? Remember student, ester hydrolysis, this carbon oxygen bond has partial double bond character because of this resonance, so it is relatively stronger. So for hydrolysis of ester, acid concentration need to be more, temperature need to be higher. What is the temperature? 0 degree, mild, and it's a very diluted acidic medium, so that is not possible. So if you know this basic common sense about chemistry, you can come up to the right answer. Okay, so this is the answer of today's discussion. And one additional information I want to share you, this part, it's called ethyl diazo acetate. Okay, so this molecule is very unique. If you give it radiation or heat in terms of metal catalyst, it undergo decomposition. Decomposition means this bond get broken, it produces nitrogen gas, very stable molecule comes out, and it produces a carbene, student. CH here, this is okay, and this carbene is significantly reactive enough that it can react with benzene. I mean, you may consider it's a carbene addition to double bond. You will say sir, a benzene delocalize, is there any individual double bond or localization of pi electron density? No student, but this reagent is very reactive. That's why reaction happened and produces this cyclopropane ring first. Later on this ring opening occurs and ultimately produce this cycloheptatriene derivative. So you can expect here from 6-member ring you are getting 7-member ring. It's a very interesting information, we shall discuss in some other videos. So this is the end of the discussion. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye.